Okay, we're going to be talking about open and closed circuits. This should not take too long. You will use your whole page. I would go on ahead and set my page up. I've written closed circuit a couple lines down just to give myself enough space. And then about halfway down the paper, I did open circuit. That's all you have to do to set it up. For a closed circuit, you're going to need at least 3 things. A battery, wires, and a light bulb or a bell. Really, you can replace this with anything that is powered by electricity. So, a typical closed circuit. Like we said earlier, we'll have our battery. I'll put it down here. Got the negative side and the plus side. We've got our light bulb. And we've got our wires connecting everything together. The closed circuit means everything is complete and there is no breaks. There's no gaps in between the wires or the bulb in the bulb or the wires in the battery. Sometimes we might also add a switch. And that would look like, let's say you had your light bulb. And I use a light bulb because it's just easier to draw. You still need your battery. And you'll have one wire connecting the battery to the light bulb. In between one of these wires, you're going to have a switch. I'm doing my best to draw a switch. That switch will connect to a wire on both ends and connect to your battery. So when this switch is down, so when this is all completely closed and there's no gap in between, you have a closed circuit. When you have an open circuit, you have a battery, wires, light bulb, or a bell, or anything that is powered by electricity once again, and you can have a switch. So we can have a regular circuit with our light bulb, battery, and wires. You know what? I forgot to put positive and negative up here. Instead of the wires being connected all the way around, at some point there's going to be a gap in between. So this gap here, let me get a pen. This gap is what's going to cause our light bulb not to turn on. Up here, these light bulbs are bright and shining. Down here, we're in total darkness. So the break or gap stops the circuit from working. If we had a switch, we'd have our light bulb, we'd have our battery. Now I'll put our switch in over here. The switch would now be open and no parts of it would close, so it would be up. If the switch is up, it is an open circuit. So our wires are still connecting to everything, but because that switch is up, we have an open circuit. Okay, I'm not going to give you any summary on this video. Yes, I am. For your summary, and yes, you should still have space to do a summary, I want you to tell me the difference between a closed and open circuit.